Okay, so today we're going to talk about music and Noah.
Let's go.
Yay!
Huh? Alan, we will officially ace this class now.
You know what?
Why don't you just go in the back and find a dog? What? I'm gonna take a long walk up a short pier. Let me tell you what shit. She do. The facts. I don't know what that is. I don't know what that is.
Also, those of you using Blackboard, every lesson up to this one is now on Blackboard. Make sure that I got everything. Everything is now up there for those of you who like to look at. Alright, so last week we started, gentlemen, by talking about tangent lines, which are, of course, lines that intersect the circle, lines from outside a circle that intersect the circle at one point. Today we're going to focus on chords and arcs. So we have up here the definition of a chord. A chord is just any segment that connects 2 points on a circle. Notice how the chord does not necessarily go through the center. You can have a chord that goes through the center of the circle. We just wouldn't call it a chord. We would call it what? It goes all the way through the circle. It would be the diameter.
That was my next guess.
All right. This circle doesn't have to do with the definition of chord. That's a separate thing. Okay, so I do want to bring up, and this circle has to do with a theorem I'm about to give you. So we're going to have the theorem, and we're going to have its converse. Okay. So we have the theorem that says. So we have a theorem, and we have its reverse, otherwise known as its converse. Basically, if you have a circle, or even if you have more than one circle, you have congruent circles. If you have an arc that is congruent to another arc, that means that the corresponding central angles are congruent. Or actually, that's the converse. The theorem says if you have central angles, in other words, if angle AOB is angle to C, so this angle here, AOB, is congruent to this angle here. So if angle AOB is congruent to angle COD, so you have central angles, then, if you have that, then arc AB is congruent to arc CD. So if the two angles are congruent, it means that the corresponding arcs. Here's AB, here's CD. So if the angles are congruent, then the corresponding arcs are congruent. I broke the banana thing. The converse simply says the opposite. That if the arc is congruent, this kid,
I went to Comic-Con.
I know what you're talking
Yes, I do.
Okay, the second theorem says that there's a relationship between the angles and the corresponding chords. Now remember, a chord is simply a line segment that connects 2 points on a circle. So if I take these 2 points and I connect them, and then I take these 2 points and I connect them, which is A. So I can now I have a theorem that before I had a theorem that related the angles to the arcs. Now I have one that relates the angles to the chords. So now I can say that if my angles are congruent, then the corresponding chords are congruent. So if angle AOB is congruent to angle COD, then chord AB is congruent to chord CB. So again, put symbolically, if angle AOB is congruent to angle COD, then AB is congruent to CD. And the converse is also true. So if you're told that AB is congruent to CD, then angle AOB is congruent to angle COD.
It's not a banana.
Okay.
Just look it up on the way.
Theorem number 3. Okay, theorem number 3 says that if the chords are congruent, then the corresponding arcs are congruent, and the converse says the reverse. If the arcs are congruent, then the corresponding chords are congruent. So put symbolically, if AB is congruent to CD, then arc AB is congruent to arc CD. And the reverse is also true. If arc AB okay, again, if the arcs are congruent, then the corresponding chords are also congruent, and vice versa. If the chords are congruent, then the corresponding arcs are congruent. Okay, so the last theorem relates to chords. So if you have 2 chords and they are equidistant from the center of the circle, in other words, if EO is congruent to OF, I'm sorry, it's not an if, it's just that, yes. If the chords are equidistant, then they are congruent. And the reverse is also true. If the chords are congruent, then we can conclude that they are equidistant. So, if OE is congruent to OF, then AB is congruent to CD. So if this line segment is congruent to this line segment, then this chord is congruent to that chord. AB is congruent to CD. The reverse is also true. converse is also true, that if the two chords are congruent, AB and CD, then they are the same distance from the circle, OE and OF.